So for the A level chromatography, we have to just make sure that we are going into a very important portion like this, right? See, suppose what is chromatography is a separation technique. First, you understand, right? When you talk about chromatography, chromatography is a separation technique, right? Now, what do you mean by separation technique, guys? Can you tell me? A separation technique is a process by which we separate mixtures from each other, isn't it? Clear? We separate mixtures from each other. Got it? Understood? We are separating mixtures, right? Suppose if we're taking a mixture, right? If you're taking a mixture, right? A mixture, it can be homogeneous or heterogeneous, right? Isn't it? Can be homogeneous or heterogeneous, right? A homogeneous mixture is called as a solution, right? Clear? A solution contains two parts, right? Solute and the solvent, right? On this, right? This bit is important, right? If you see a solution is a homogeneous mixture, right? Such as salt water, right? Such as milk is a homogeneous solution. Pepsi is a homogeneous solution, right? Heterogeneous is what? Salt water, right? Sorry, sand water, right? Mud water, heterogeneous solution. A solution can be of two types. Sorry, heterogeneous, homogeneous. Homogeneous is called as solution, right? Clear? A solution contains two parts, a solute and the solvent. What is the solute? Solute, if you see, what is a solute? Solute is the lesser percentage component. Write down, right? Fine. Lesser percentage component of the solution. Please write down this, right? What's a solvent? Solvent is the higher percentage component, right? Write down this, right? What's a solute? Solute is a lesser percentage component of a solute. Sorry, solution. And solvent is a higher percentage component, right? Well, higher percentage component of a solution is called as a solvent, right? Right. So solid is a lesser percentage component of a solution. Solvent is a higher percentage component of a solution. Now to separate out the solute from the solvent, which process we do? We do crystallization, right? Did okay. Now in countries such as UAE, right? Suppose seawater I'm taking, right? Seawater in UK we need the salt. We have ample water. We don't need the water. We need the solute. So we do crystallization, right, to take out the solute. Now, see, in UAE, they need the solvent, right? Water they need. They don't have any lake waters or rivers, right, or rain. Solvent. We're taking the solvent from the solution. What process do? We do simple distillation, right? Now see. Now we have got what? We have got a special process called as chromatography. What is chromatography? Chromatography is the process when we have more than one solute. Is it clear? Do you get my point? Understand this part? Do you get my point? What's the meaning of the word chromatography? Chromatography is the process by which we take out. Suppose in a case we have got more than one solute, solute one, solute two, solute three, mix in a solvent, right? Tiara, Snigdha, understand this word? Suppose
Yeah.
in the chromatography, what we do, we get a special case where there is more than one solute mixed in the solvent. So what is chromatography? Chromatography is the process by which we separate out different substances from a solution. Do you get my point? In all these example we did NaCl, water, only one solute was there, isn't it? One solute. But in chromatography, what we do, we separate out different solutes from a solvent, right? Now, in this paper chromatography, you have to understand that the basic chromatography, you have to understand this. Suppose we are taking ink. What is ink? Ink contains three solutes: red, blue, yellow, right? Three solutes we are having: red, blue, yellow, right? Isn't it? We're having three solutes. Now remember one thing, that if we have got, if we take the ink, we drop it and we dry it, and after that we are doing what? We are adding a drop of solvent. That is water, right? Now over here, what happens? The water will be spreading like this, right? Water will be spreading like this, and when water spread like this, what happens? You'll be seeing that the yellow color traveled the fastest, right? And the blue color traveled the slowest, right? And the separation of the solutes happens. Can you see this? They were separated out. Now, Taylor, can you tell me that which color was most soluble in the solvent which is used, that is H2O? Which color? Yellow or the
Yellow.
yellow? And which color is the least soluble? Snigdha, can you tell me which color is the least soluble in the H2O? Tell me.
The blue.
Blue, brilliant. So chromatography does this. It will be taking these differential solubilities of the solute in a particular solvent, right? Is it clear to you? If you take ethanol, the answer might be reversed, because this blue solute might be more soluble in ethanol, right? Clear
Yes.
to you? So the chromatography, the question comes, will be depending upon the solvent taken and the chromatography paper taken, or so this solvent which you take is called as what? Is called as a mobile phase. Understood? Solvent is called the mobile phase, right? This paper, or in thin layer chromatography, we are taking a glass plate, and we plastic sheet of a silica gel. That is called as the, tell me, stationary phase. Is it clear to you? Right? Is it clear to you? In paper chromatography, we have two things. Mobile phase is a phase which travels. Stationary phase is a phase which will be stagnant. Is it clear? Is it clear to you? Do you get my point?
Mhm.
Now, in this paper, in this chromatography, we have to see that the if the now tell me, if the solute, right? If the solute, suppose I'm taking the chromatography like this. Now tell me, if this solute, right? If the solute is more traveling, what does it mean? It means that ultimately the distance the solute travels, right, depends upon what? The distance the solute travels will be depending upon the different solubilities or different attraction of that solute in the stationary phase and the mobile phase. Is it clear to you? They will
Mhm.
be having some attraction to both mobile as well as stationary, right? Now my question is that if a solute has got more attraction forces in the mobile phase than the stationary phase, will it travel faster or slower? Zoom chat, go and answer. Do you get my question, Tiara? If the
Yeah.
solute has got more attraction in the mobile phase than the stationary phase, more attraction in the mobile phase than the stationary phase, will the solute travel faster or slower? I've written yes, faster. Now, opposite will be true. If the solute has got more intermolecular force of attraction with the stationary phase, right, than the mobile phase, will it travel slower or faster? Please tell me. Fine. Which one? Sent. Okay. Very good. Did you get my point? Easy now. Absolutely easy. This part, this bit of the A level per chromatography, right? You're having.
Mhm.
All just remember this thing. This is a very important method. We can separate out similar solute from each other. Write down from each other. Is it clear? Understood? Similar
Mhm.
solute from each other. Is it clear? See the amino acid. Amino acids are similar, right? They're almost similar solutes, right? Is it clear? They're almost having similar solutes, right? Isn't it? So how do you separate them out? You separate by chromatography, right? Clear? Is it clear? So,
Mhm.
so, the, so the choice of the suitable mobile phase and the stationary phase will be very crucial because they are having similar solute, right? Almost similar solutes to separate out. Clear, everybody? Did
Yeah.
you understand this part? Now, the
Mhm.
first example is that the maximum uses the thin layer chromatography, or it is fondly called as TLC. In the TLC, we do what? Just remember one bit. I just forgot to tell you. Now, if you see that when we talk about when we are trying to talk about the RF value, RF value is what? Is the distance moved by the solute X divided by the distance moved by the solvent. Is it clear? Y. Is it clear? And RF value is a ratio of the movement. And RF value will be constant of a particular solute in a particular solvent, isn't it? If you change the solvent, the RF value changes. Understood? So from the RF value, you can identify a particular solute. Is it clear, everybody? Tara, Singha, understood?
Mhm.
From the RF value, we can identify. If you change the solvent, the RF value changes. RF value is a constant of a particular solute in a particular solvent. This is very important, right? Clear, everybody? Do you get my point? Fine. So it's a
Mhm.
very important point we have to nurture, right? Now, if you see the thin layer chromatography is what? Thin layer chromatography, we are taking the stationary phase. What? In this stationary phase, what you're taking? The filter paper is replaced by a glass, usually, right? Understood? It can be a glass or a metal. It can be a plastic sheet also, right? Right? In the cheaper TLC. but you take a thin layer of silica gel, isn't it clear? Or you can take alumina. Do you get my point? Tera, is it clear? You take a plate, think that's plate, and the coating of what the coating of a silica gel or alumina, right? Usually silica gel is actually preferred, right? Clear?
Yeah.
So this is a stationary phase. Is it clear? This is a stationary phase, right? Understood. Now next what happens? Now you're having what? This sheet is cut to sizes, right? Now what are the advantages of it? The advantages over paper chromatography. Please open your book, please open your book to this page 33.1. Mark it important. It runs faster. This is very important. Smaller amount of mixtures can be separated out, right? Clear? Is it clear? The spots are less spread out. Understood? Or smudging is less. The plates are more robust than the paper which you use, right? Is it clear? Do you get my point? Now see, amino acid, if you take amino acid, does not have any color. What we do? We can either spray a locating agent. See, understood this thing. Amino acid is not colored, right? Not colored. So how can you find out the amino acid? Please tell. What's the locating agent used? Nikita, can you tell me?
Was it
Neem
knee
hydrin.
hydrogen?
Neem
Yeah.
hydrin. Or you can shine a UV ray also.
Yeah.
That also is done. Clear? Get my point? Understood this part? Thank you.